everybody. Reporting to you again from the Glamour City, Hollywood.
So essentially, we have a signature for every single industrial athlete and how they operate. So if we see significant deviations, that's when we go in and we prompt the coach or the manager to actually go down and have a conversation. So if there's a limp, if there's a severe drop in efficiencies, if there's a severe drop in any aspect of the safety score, the manager will be alerted and can go have a conversation with that individual. So it's not invasive, but it provides a very clean way to understand what those deviations are. And then we're encouraging a very easy person-to-person interaction. And the reason we do that is we can collect as much information as we want, and the wearables are incredibly successful. We have a ton of patents and we're really proud of it, but there's nothing that is more powerful than a safety culture that's positive.
If you love listening to this show, please consider giving a rating and a review on Amazon Alexa or wherever you listen. We want to continue bringing you this amazing content, and part of our ability to do that means that we need a big audience. Now, it may not seem like much, but rating and reviewing the show will help more people find us, just like how you found this show. Simply on any podcast platform, search for a show, scroll down to the bottom, and push 5 stars. It's that easy. Thanks for supporting the show. Today, I'm joined by Sean Petterson, CEO of StrongArm Technologies. Welcome to the show today.
Thanks for having me. Great to meet you.
So, Sean, what are some of the most common types of injuries at work in an industrial context? And some of those injuries, I wonder, are they oftentimes preventable?
Yeah, I think punchline is I believe almost all of them are preventable. The most common workplace injuries that you'll see are MSDs, so musculoskeletal issues. So that is your push-pull, your strains, your sprains, and issues you have related to manual materials handling. In the United States alone, that equates to about $60 billion a year spent on these problems that, again, with proper behavior change, with training, with the right equipment, with the right data, are all solvable, in my opinion.
Now, this is of a heightened risk. Of course, it already poses a fiscal as well as a productivity issue, because if people go on disability leave and so forth. But in the context of labor shortages and supply chain issues, this has even a greater gravitas in terms of the importance of making sure that workers are healthy and safe. And I wonder, can you talk about how the current post-COVID situation has made it even worse, or even more important, more paramount to be able to actually measure these things and prevent?
Yeah, absolutely. So when I think what's relevant is just how we address COVID and for our clients. So right at the swings of the pandemic, when it started hitting the United States and businesses were shut down, we saw obviously our manual materials handlers, our warehouse workers become frontline workers. And in that vein, we had huge issues with hiring because, first of all, it was difficult to hire in that environment. There are already high injury rates in these environments. And now with COVID, you can't bring anyone new in. And in addition to that, the environmental health and safety folks that are responsible for managing these injuries and the compliance and training associated are now dealing with a whole new beast, which is contact tracing and social distancing. And being able to implement those things functionally in order to get their businesses up and running took a great deal of attention. In addition, those groups are also working remote. And now we've seen a giant chasm only continue to increase in terms of EHS, the needs for compliance, and how that's translated down to the people who enact it, which are the floor managers, the shift managers, et cetera. Those shift managers are also dealing with way increased loads. They're dealing with a lean staff, and they're also now getting their direction remote from a body that is basically spending half their time on the pandemic. So our data showed us that right in the middle of the first year of the pandemic, injury rates increased across the country by about 35%. Now, what we were able to show with our devices, which are measuring and assessing the risk of industrial athletes and providing alerts in real time to avoid injury, that with that type of data and that haptic feedback, we were able to automate a great deal of those EHS compliance needs. And those injury rates, instead of increasing by 35%, continue to trend downward 16% month over month. So an example there about how these things are solvable, but the issues still persist. So now that we're on the back half of COVID, a lot of these organizations are still comfortable with this remote environment. And there really just needs to be a connective thread between the needs of environmental health and safety and how that is translated down into operations. And the truth is, there just hasn't been any relevant contextual data to allow those conversations to have. So us providing real-time on-body data from the risk of the industrial athletes allows us to really be that segue into a discussion around how we need to articulate the physiological capabilities of these industrial athletes alongside decision-making for operations and demand plan. And if we're able to do that correctly, we see results not only in the injury reduction, but we also see an increase in retention. So we're increasing retention by avoiding these injuries, but also just providing an environment where it's easier to work in. And for us, those results are, 15 and upwards of 45% in some of the businesses that we operate. So as we're looking at not only attracting new hires to work at these businesses, we want to retain the tribal knowledge, keep the people safe, and keep the people that we want working at the job. So that becomes a really new and interesting way to look at the importance of having this type of data.
Yeah, so as I'm listening, I think what's really insightful is that COVID has brought new trends, behavior, and operations that really, for the last maybe 30 plus years, we haven't seen those kind of changes or shifts. And of course, there's a lot more demand for those that are managing at the factory level as well. Mm-hmm. So coming back to this, I don't think we did a proper kind of an introduction of StrongArm Technologies. And tell us a little bit more about the company and how are you helping to increase productivity while trying to get to zero injuries?
Sure thing. So, our goal isn't necessarily to increase productivity. It's simply to find the efficiencies where right now companies are spending a great deal on injury costs. And we're trying to find the line in between where if you are really focused on the actual health and safety of the industrial athletes, that there's a thread there that you can marry that into operations. And what we're looking for is a win-win. So what StrongArm does is we provide wearable solutions for large organizations in the warehousing, manufacturing, construction, and heavy industrial space. So our wearables are a very small device that is clipped onto the shirt of an industrial athlete at the start of their shift. And that device is preloaded with firmware that knows what job they're doing that day. So it understands what environment that industrial athlete is going through and will provide alerts based on ergonomic risk, proximity risk to moving objects or autonomous objects on the floor, heat risk for those working in very intense environments where heat exposure is an issue. And we're tying that all into a streamlined time series database that allows us to marry that again back into demand planning. So with that kind of vein, what we're doing is giving a voice for the industrial athletes in the decision-making process.
So I want to go a little bit deeper into the fused safety wearables and the components and the capabilities that you're referring to. So I think I heard things like gyroscope, accelerometer, perhaps maybe a thermal, galvanic skin response. What kind of sensors are actually embedded in this device? And then you mentioned that there's a benchmark. So depending on the tasks that they're given for a day, there's a benchmark or pattern of what they're supposed to do. And it's basically comparing the actual human movement to the recommended movement and looking for those deviations, correct?
That's correct. And where StrongArm actually started is we tried to solve this issue of workplace injuries through bringing attention into the space. And in order to do so, we created exoskeletons. So those exoskeletons were the first massively deployed passive exoskeletons in the market, and they were really successful in reducing lower lumbar injuries. But as we scaled that solution, we looked to find ROI data that we can provide our clients, and it turns out that there's no way to actually find that baseline. And the reason for that is the industry itself is, a VHS is in practice about 60 years old, and they're still using tools from 30, 40 years ago. So they're using static observatory tools in a very dynamic, high-paced environment with high turnover. So the baseline information that was created really had a 30% observatory bias. it was designed. Is built on a very again static workloads where you're doing equations, you're taking pictures, and you're translating that into some form of a subjective risk calculation. And then it's very difficult to actually calculate that to an ROI. So how do you get clients to care? They would look in their actuarial data and look 12 months retroactively, but in some of these environments, the turnover rate's 100%. So you completely turn over the workforce. You're looking at numbers, and the supply chain has just increased so rapidly. COVID only made that worse. So there are really no figures at all. And we said, if we're going to make an impact in this industry, we need to create that baseline. We need to democratize the technology that we utilize to really validate the exoskeletons in the laboratory and make that available in real time. And then take that data and drive insights that are relevant to everyone in the value chain so that we can all say, this is why we should invest in the industrial athlete. So with that, the baseline information that we're collecting is a whole new risk paradigm around very specific job tests that are performed inside of the environments we perform. Those job tests now are giving a baseline that allows us to compare not only site by site, shift by shift, but industry by industry. So we're creating a new baseline for understanding exactly what the risk profiles are of every single job type and also every single person working those jobs across the globe. And with that, we're creating a way to, again, create a conversation around constant improvement. So how your safety score increases directly impacts your ability to retain talent. It directly impacts your ability to understand throughput, and it's giving a new window into supply chain continuity. And I think it's that visibility that we're adding that really gets the operators involved and interested. And what's probably most relevant are some of the case studies that we find this golden matrix between physiological data and operational throughput. So one of the cases that we had worked on is warehouses today, particularly in pick and sort jobs, they're incentivized per package. And that incentivization structure is simply driven by a binary output. How many packages can you get out the door today? And that may seem like a good idea, pay people more to work a little bit faster. But if you really had the data, you'd understand that exposing the industrial athlete to that much more risk is actually severely negative on your bottom line. So one of the studies that we've done is where this warehouse was paying 10% for every package that was as an incentive for their package rate over 100%. At 105%, the break even on increased injury exposure to package throughput profitability was relatively break even. So we said, we're not going to slow down this operation here by any means, keep doing what you're doing. But every single package over 105%, the risk increased by 10x. So much so that when they had individuals working at 120% of their daily productivity needs, the organization was so backwards on their ROI because of the injury expense that they might as well have just stopped the whole day at 80%. So what we came up with was a new way for them to actually manage the productivity of that workforce. And we said, let everyone work at their own pace. When the overachievers hit 100%, pay them for the full day and send them home early. They're happy because they're saving 2-3 hours, and most of these individuals are working 2 jobs or have kids at home, so they greatly appreciate the extra time. And those that aren't working as fast can just finish their shift at their own pace. And with that, we saw injury rates absolutely plummet, and all the needs of the facility were made on time and predictably. So it's, again, just a really unique way to look at data and how there can be a win-win. If you focus on the physiology, you're going to get the right productivity. And the way we look at it is slow is smooth and smooth is fast.
So you bring up some really interesting points. And firstly, from an insurance premium risk pricing model for disabilities, long-term disability, and so forth, worker comp, this is hugely valuable. So I'm just thinking from an insurance data point, that in itself is a huge win and opportunity for monetization. But the other part that is kind of embedded in what you're sharing is this notion of change management. So even if the data and the modeling suggests a optimization of not just throughput, but the risk aspects of injuries, to tell a production floor saying, hey, some people can go home, some people can stay longer, that kind of goes to the counter of the kind of the culture of many of these kind of industrial jobs, right? So I wonder, how are you addressing that?
You know, we're addressing it with the hard facts, with the hard ROI, right? So I think you touched on insurance. We have been working in the insurance field for about 4 years now, and we've allocated around 250 million historical claims cases and paired them to over 30,000 individual worker data files. About 40 million hours of on-body worker data is what we have. And what that very broad correlation showed us is that we'll impact the loss costs of a work comp premium by up to 35%. So that is a huge savings that we can offer. And what that entails is allowing clients to align incentives. So we've been essentially fighting the good fight, putting all the data in the right places to encourage companies to make the right decisions. But to be totally frank with you, COVID and this hiring environment has really been the biggest catalyst for the importance of this type of study. And the reason for that is, in the past, injuries for large businesses were just treated as a cost of doing business. But now with the turnover rates and the challenges with hiring, it really has just come to bite the clients, that bite the industry in the back. And that is because, it's just untenable at this point. So clients need to do whatever they can. The industry needs to do whatever it can to get a better handle on this data and on this information as it pertains to the health and safety of the industrial athletes. And that's what we're seeing. So we're seeing folks who are looking at this information and saying, what is a better way to retain clients? Because there are hiring battles going around for $1 an hour. And there are so many other things that you need to bake into that cost that makes it really challenging to be competitive. So it has to come into, what is the workplace environment like? And there are really good ways that we can show examples of how implementing this type of data really encourages alignment incentives. That encourages the change management solutions to really catalyze around the well-being of the industrial athletes. And from that, we're seeing fatigue rates drop. We're seeing injury rates drop. We're seeing workplace accountability increase. We're seeing utilizations increase. And all because of that, basically the idea of giving industrial athletes, again, a voice at the decision-making table, because we're sewing this into all the right pieces of the value chain.
I want to explore a couple of different areas. One is around this notion of kind of data that you're currently capturing, and is that sufficient? So in other words, perhaps maybe from a physiological movement and converting into like a 3D vector animation and comparing it to the baseline and deviation, I get that. But one of the things that I think we have to be mindful is there are a lot of other things that can contribute to not only the well-being, but the optimal alertness and performance of an industrial athlete or worker, including the use of opioid or cannabis, for instance, right? So there are actually startups that are trying to measure who has actually smoked weed recently on the job, for instance. Others are thinking about focus, because if that worker from the previous night didn't sleep well, even though from all past data patterns, that person usually does very good and is less likely to be injury prone, but that lack of sleep the night before is an indicator, but doesn't necessarily get fully manifested in the form of the data that you're capturing. So how do you account for some of those aspects?
Yeah, that's great. And all the points you touched on basically revolve around understanding the behavior dynamics of the industrial athlete throughout the day-to-day. Sleep is the biggest thing that we're focused on getting a data stream from next, because being tired is actually in many cases worse than being inebriated. And what we're looking at here is a way to understand how much information we can get without being invasive. So all the information that we allocate is from essentially the idea of exposure. So same as we have heat exposure, proximity exposure to risk, we also look at musculoskeletal injury as exposure, because these are accumulative injuries. So if you're exposing yourself to high flexion, to high fatigue, to high twisting velocities, those are all things that we're treating as accumulative and then providing you an alert to help avoid that. When we provide those alerts and we're collecting that data, it's on a time series database. So essentially, we have a signature for every single industrial athlete and how they operate. So if we see significant deviations, that's when we go in and we prompt the coach or the manager to actually go down and have a conversation. So if there's a limp, if there's a severe drop in efficiencies, if there's a severe drop in any aspect of the safety score, the manager will be alerted and can go have a conversation with that individual. So it's not invasive, but it provides a very clean way to understand what those deviations are. And then we're encouraging a very easy person-to-person interaction. And the reason we do that is we can collect as much information as we want, and the wearables are incredibly successful. We have a ton of patents and we're really proud of it, but there's nothing that is more powerful than a safety culture that's positive. But that's been impossible to metricize. But today, because we have every athlete in a warehouse wearing a sensor and we have all their managers engaged with their data, we're able to really break down the barriers of communication. We're able to have real coaching moments that are encouraging. And we actually track those and gamify those. So we're giving coaches the ability to have a goal to strive for, how many people you can talk to. And we immediately see that the more coaching moments that happen on the floor, it directly correlates to a drop in injury. So it's all those types of factors that a time series database enables you to really get granular on those signatures, look for the deviations and figure out where can I intervene? How can I make this? How can I change this solution? Or how can I just talk to the individual? And I think that conversation is more powerful than anything. And that's where we're focusing our data allocation on next.
Yeah, makes sense. Now let's look at it from the perspective of the worker, because again, they're getting paid, let's say, just a little bit above minimum wage, 13, 16, maybe 20. And they're being asked to take a urine test, sometimes blood test. They're having to do puff, to see if they're taking drugs. And now they're having to strap on wearables. From their point of view, they feel like this is invasion of privacy, and they feel like, gosh, they're really trying to not just observe me from a computer vision aspects, but they're trying to measure me at a physiological level, biometric level. How is that resistance overcome in a positive way? You mentioned culture, and also I think there's that principal agency issue here as well, right?
Yeah, it comes down to respect. And I think that, I grew up in a construction environment, and I think that it's really lost in a lot of folks that are trying to solve this problem as well from other angles, where you can't just try to force somebody into being a robot. You can't just try to force somebody into a card. And, some folks can use this data in harmful ways. And I think that's what differentiates StrongArm, is that we're built for the industrial athlete. And our goal is to keep them proud, protected, and productive. And I think proud and protected really revolves around the data and the utilization of that. So what we're doing is spending a great deal of time on data science and data engineering, embedding APIs with the right software systems and legacy systems that exist inside of these environments, so that we can show that it's a no-brainer to have this type of data. And by doing so, marrying the efficiencies to proper interventions that we recommend means that you don't have to be punitive. And in fact, if we find out that a client is being punitive, we have them sign what's called a safety pledge. And that safety pledge says that if we find out any of this information that we provide is used for punitive action, we'll redact the platform so that you won't know what the athlete is. You'll just simply know what the job type is. So that puts the onus back on the EHS, back on the managers and operations to perform interventions and invest based on job type versus on an individual level. So I think we rarely have to pull that card. I think we only had to do it once. And it's really just a matter of us continuing to shepherd the good use of the data, but providing an ROI. And that ROI is not just in injury savings, which are significant, but also in areas where we're showing retention rates and we're showing turnover rates and calculating the cost of hiring, replacing replacing that tribal knowledge, replace the need for training and onboarding and all these things that say, if you just do it right the first time, care for that industrial athlete, you won't have to replace them. And you won't have to incur all those costs and all the headaches around it. Just start with a stable safety culture, but find a way to metricize the safety culture. And the best way to do that is with this type of system.
I want to switch the conversation to something that's quite interesting. So let's use the metaphor of golf, for example. When we play golf, it's a muscle memory. many times, many athletes and the kind of sports we play, it's hours and days and years of training that has gotten embedded into our muscle memory. So
Right.
one of the things challenge with industrial workers is the fact that there's a high turnover, which basically fundamentally means so you have constantly new crop of people coming
Yeah.
in that
Right.
may not be very familiar with the task. So let's think about meat packing and the tasks that's involved, not only from an injury perspective, but through the haptic feedback aspects. How
Mm-hmm.
can the system almost help train to help develop muscle memory for a particular task so they can be better at it as a newer worker?
Yeah, that's a really great question. So if you look at your astute observation around the challenges with these new hires and turnover, there's just less time for training, right? So we're seeing folks just being thrust into these jobs, and the industry standard during peak season is that you're going to hire 150% of your workforce for the months of September to January, and you have an anticipated churn of 150%. And the truth is that is just untenable because they're eradicating the labor forces for miles around some of these dense logistics cities. So when we talk to our clients and we ask them, why are these turnover rates so high if it's not just injury? And they say some people just realize they're not cut out for the job and they quit. And we say there is no way someone is bussing in an hour just to come lift boxes for 10 hours a day and then bus an hour home to their kids. These people are hungry and they want this job. So we were able to get granular in some of that new hire data. And what we found is that particularly in logistics operations, and similar to some of the meatpacking ones, you're seeing the opposite, where we looked at the new hires and we saw that they were actually performing at a rate 4 times that of the tenured workers. So they were coming in, they were trying to earn their seat at the table, try to get a tenured work, and they were exhausting themselves. That exhaustion leads to mistakes. That exhaustion leads to some of these challenges we try to tease out, and that's where the injuries happen. So these individuals were either quitting because of embarrassment of getting fired or because they were really concerned they were getting hurt. What we were able to do is simply intervene and say, what we're going to do is actually put the new hires on this side of the warehouse or operation, and we're going to put the tenured workers on this side. And what we're going to do is we're going to monitor the safety score of these new hires. And as their safety score increases, we can then increase their workload behind it until they're at a cadence that marries that of the safety scores for the tenured workers. And what we saw there is an easy transition. It's almost automated on-the-job learning because we're able to throttle that with our safety score, with the haptic feedback. That enabled us to almost completely reduce that new turnover rate, which was happening in the first 90 days, completely transition the way that these organizations that we serve are doing their hiring and retaining a much more stable, educated, and healthier workforce in the long run. So it's that type of nuance that you can pick up in not only learning about new hires, but then also learning about this behavioral change. So as we're talking about muscle memory, the way that we encourage that is essentially through micro-learning. So we'll go in and we'll assess multiple factors, all at a range of about 12.5 times a second. Now, what we're doing is not alerting every single one of those factors at a time. We'll focus on one motion at a time per day, and then we'll orient that differently. That helps us train in essentially microblasts, because when the individuals come back to the dock in the morning, we'll tell them what went wrong and what they can improve. It could be taking a pivot step. It could be bending with your knees. Very simple bits of information delivered at the start of the shift, keeping that top of mind, and then constantly retraining and making that dynamic. That helps us avoid haptic fatigue. It helps the industrial athletes keep it really easy to figure out what they need to improve upon. And then we see a steady increase in the safety score and a reduction in injuries as a result.
Well, I think the way you explained it from a metaphor perspective makes perfect sense as to why you refer to the workers as athletes. So in that regard, I think this is spot on. My last question for you is, you've been at StrongArm Technologies really seeing these massive tectonic changes, and also learning a lot in the process as well. There's got to be lessons learned, either projects or product failures or just insights that you've gained. And I wonder if you could share that with others.
Yeah, I think we built this with a team of data scientists, with mechanical engineers. We've solved this with the best ergonomic experts in the world. We've been all around the planet, and we really learned that we applied so much technology into the solution. And at the end of the day, we have to humanize it. We have to make it simple. And I think the simpler we are, the more successful we are as a business. And for us, that means not only making it simpler for these microblasts and these behavior changes to be understood and interpreted by the industrial athlete, but also really simple metrics for the whole organization to keep a pulse on, and really doing our job to continue to shepherd that through the value chain has been the most important aspect for us. The next most important aspect has just been on future proofing and always staying ahead of the curve in terms of learning how the environment is changing. Right now, we're in this mix of learning what happened in Industry 4.0 and transitioning into what may be called Industry 5.0. I think the terminology on that is still not quite set in stone, but the underlying language is that humans were left out of the equation. So humans are essentially, I think Elon Musk said this, humans are underrated, right? And we thought that we could roboticize and automate everything, but the dynamic, most thoughtful, most capable piece of the equation, the human being, has been left out. There's been a device attached to every single machine in the warehouse. You can run it like a control room, but those are all very siloed technologies that don't really marry themselves together. And when it hits the floor, there is really no consequence for these machines as it relates to the industrial athlete. And what we've seen is that all this automation has only increased the burden on the industrial athlete themselves, whether that be because a robot is making their movements much more succinct and you're seeing repetitive motion injuries, or just generally the congestion of the environment is so much higher risk that it becomes a much more challenging environment, filled with lots of distractions and higher workloads. So what we need to do is be the connective tissue that threads all that together and marries it down into demand planning, and allows all these systems to really talk to each other by giving humans that same level of data science that's applied to the machine health world, but now doing it from a productivity, from a throughput, and from a safety standpoint, where we essentially find that golden triangle of success that is an optimized workforce based on the physiology of it. And I think that for us has been the newest vein. So as we push forward, we're focusing on safety culture and how to get people just talking about the right things.
Well, that's a terrific recap. And with that, I have been joined by Sean Petterson, CEO of StrongArm Technologies. Thanks for joining today.
Thanks so much.
If you've enjoyed this episode, take a moment to rate our show on any podcast platform that you listen to. Scroll down to the bottom and push 5 stars. It's that easy. And as always, thanks for listening.